Our second speaker today is Dr. Xiong, and she is also at University of Missouri. She's an associate professor, and she's going to be talking about the ARDP grant that she got from NIFA entitled Developing a Novel Mechanical Strategy for Control of Billbug.
So today we are going to talk about this very focused research report that is about to develop a novel mechanical strategy to control the billbugs. So what is a billbug? Billbugs are very tiny weevil, so they cause the damage to turf grass species like this. What you see here is an image taken in May of that particular year on a zoysia grass fairway. So what you saw is during the spring when the zoysia grass as a worm seed species now started to grow, breaking the dormancy, then with certain arrows show the damage like that. So under the field condition, it could be easily misdiagnosed with other issues. People could think this issue is caused by drought, any other pests, including white grub, but matter of fact, they are caused by those problems called billbugs. So there are 11 different species of billbugs in North America that could cause damage on turf grass species. And here in Missouri and the surrounding states, we have primarily those two species of billbugs. With the left one on your screen is the bluegrass billbug, and the one on the right is the hunting billbug. The hunting billbug in the past was believed to be a southern pest that's mainly a problem for worm seed species, but now in recent years, we found this to become an emerging problem in our state and the surrounding states. So billbug in general, the female started to lay the egg, and then the egg is going to hatch, and they're going to actually burrow into the stem of the grass plant and start to feed within the plant. And then once it become bigger, the larvae actually look like a little bit like a white grubs. White grubs is the larvae of the beetle species, including Japanese beetle. But notice the differences of the larvae of the billbug compared to the what we consider the white grub, that is, it does not have the legs. Now, once the larvae grow bigger, they will burrow down to the soil and start to feed the plant under the ground. So they are really hard to find. So in the past, we believe the larvae is the primary stage that causes damage to turf grass species. But this publication in 2012 found that actually adult can cause equal or greater amount of damage to the turf grass species. So this study actually fed different number of larvae or adult to the zoysia grass in a PVC pipes, and then assess the percent of greenness. How was that affected by the number of these larvae or the adult billbugs? And what this study found, the hunting billbugs, when the number of adult increased, you can see the significantly decreasing of the percent of greenness of the zoysia grass. So this research result shows us that both the larvae and the adult stage are damaging stage for our turf grass plant. The another thing made to control the species particularly difficult is the size of this pest. So on this picture on the left showing you the full matured adults, you can see how small they are compared to the tip of the pen. So typically their size is less than half of inches once they fully grow as an adult. And the larvae, of course, are even smaller. This is one larva. You can see that how that compared to the size of a penny. So we understand that the larvae spend the most of the time either hidden within the stem of the plant or they feed underground. This is the picture taken October that particular year when we found the damage on a local sod farm on a zoysia grass sod. We use a sod cutter to peel open the sod. You can see the larvae actually at that time, later part of October, we're still actively feeding on the grass, and this is zooming picture showing the larvae. So they are really hard to fight. And then how about the adults? So the adult turned out to be nocturnal. So this study published in 2009, the study conducted in Florida, they found that the adult hunting billbugs are engaged in different activities at different time of the day. And most time they actually stay in the soil. Those are taller bars represented, except during the evening hours, you can find that that's when they came up to the top of the turf canopy and engage in different activity, including feeding or mating. So by saying that, how are we going to even detect there is a presence of the billbug? Like I said, they are tiny, and the larvae basically spend the entire lifespan hidden either within the leaf stem or underground, and the adult is nocturnal. So the way to monitor the species to be able to determine are you going to take action or not is to install what we call the pitfall trap. This is an example of a pitfall trap that we installed on a local golf course fairway. So it consisted with a PVC pipe, and we installed a screen at the bottom, so the screen would allow the water to infiltrate, yet still be able to capture the billbugs here. Most of them are hunting. If they crawl into here, then fall to there, and they will be kept there. And this type of pitfall trap can be easily installed by using a cup cutter. And then once they are installed, they can stay on the ground year round and without interfere with mowing. So with this type of device, we are able to monitor the population of the billbug mainly by the adult activity. So this is the result from one of my collaborators from Utah State University, where they monitored the different species of the billbugs at their site. There are bluegrass, and this is a hunting, and they also have another species that we don't have here in Missouri that is called Rocky Mountain billbugs. So based on their data, what you found is they typically have one large peak activity period time for the adult billbugs, which is going anywhere from later part of May to the August. So this type of pattern is very good for them because then you can use degree model to predict the occurrence of the adult activity, therefore to help you to determine when you should put down the application to treat this pest. Here in Columbia, Missouri, however, the story is a little bit more complicated. So this is a 2 years data that we monitored the billbug population at a local golf course, Zoysia grass fairway, and the blue line is the hunting billbug, and you can see that they are the dominating species, and we do have some bluegrass billbugs on the side too, and the gray line is the total number of the billbugs. What you found is, for us, we have a pretty large peak activity for the adults during the fall, and yet in the spring we have almost 2 or even 3 peak activity time for the adult. So this is very interesting because why? Because this tells us that for us in our region, the hunting billbugs have at least 2 overlapping generations per year. So they could either overwinter as adult and then emerge fairly early in the spring, or they overwinter as a large size larvae, then pupate, then emerge as adult later part in the spring. So this makes our control more complicated because we have 2 generations a year, also have overlapping generations. Some of the data from Florida actually shows that the hunting billbug goes through more than 6 generations a year. So this is very complicated population that make our control practice is need to be more careful. Another thing added to the fact that the biology is complicated is their choice of food. Like I mentioned earlier, in the past, we believe the bluegrass billbug is mainly a cousin species pest, and the hunting billbug is a pest for warm species, mainly a pest, therefore it's for the southern state. But this is one of our research from our group collaborating with Dr. Barrett here at the University of Missouri. And this study utilized a device called olfactometer, which have 4 chambers. And each chamber would contain each of the potential food source, including zoysia grass as a warm species, and Kentucky bluegrass and tallfisky and the cousin species, and inert into a control. So this chamber would be able to force the air into the center of this device where we release hunting billbugs as a male or female, and wait them to make a decision which chamber to turn to, because the scent generated from potential food source could potentially attract them to different chambers. You can see that compared to control, there's not much choice made by the billbug to choose the chamber which is empty. So you can see that less than 50% of the billbugs, either male or female, choose the chamber that contains zoysia grass as a warm species. But there are also significant amount of the billbugs, either male or female, they choose cousin species. That's why it made the biology of this hunting billbugs very complicated here in Missouri, because we are located in the transition zone that we do grow both warm season and cool season species. As a matter of fact, on the local golf course, we typically have zoysia grass as a fairway species, and so they are surrounded by the rough, which is consistent typically of Kentucky bluegrass mixed with tall fescue. Now, with that being said, that you must be thinking, then what's our option to control the billbugs? The earlier that biology study I showed you that we collected all the billbugs were stored in a site that based on the superintendent that they think they have the worst white grub problem. They were not even aware that they had the hunting billbug issue, not to mention how bad that issue was. So unfortunately, you must the bad news is all the available turf grass species, all the cultivars we have in the market, none of them are tolerant or resistant to the billbug. So by saying that we don't have that option, so we really have to rely on the chemical options to control the billbugs. For the chemical control option, we can either choose the chemicals that are geared towards the larvae or the adult. So previous research, this was research published in 2015, showed that to control larvae really is not very effective. You can see that no matter what type of chemistry you choose, the effectiveness is less than 40%. Which is easy to understand. Why? Because the larvae either hidden inside the stem of the plant or underneath the ground. So you then you have to bring the pesticide to where they are residing on. So that's why it's difficult. Then in comparison, adult control using the pesticide, it seems like to be more effective. So some of the pesticide like Telstar, that's one of the most effective insecticide to control the adult billbugs showed almost 90% control efficacy, which is very exciting, right? You might think about that. However, another thing we want to think about, how long does those insecticide maintain the effectiveness under the field condition, or in another word, how long is the residual effect is going to be? Because the insecticide like Telstar I just mentioned about is working contact. So this is like experiment we did here at the University of Missouri. So what we did is we sprayed the field with zoysia grass, and then we collect the plugs back in the lab in the laboratory at a different time, either as 1 week, 2 weeks, all the way to 4 weeks after the pesticide has been sprayed. And then we will release the hunting billbugs we collected from the field to this device, to the PVC pipes, and cover them. And we will let them stay there for 48 hours. And then we will check how viable they are, or are there any mortality. So this is a short video I'm going to show you. This is showing you, this is the billbug survival on the plugs that was sprayed 1 week prior. You can see some of them are agitated or still moving, but some of them actually lay still on the back or side, definitely already totally dead. So this just showed you that this graph summarizes the result of that experiment. This graph basically showing you that at 1 week after the pesticide has been sprayed, so less than 20% of the billbugs we exposed to that plugs survived. So 80% of plus has been killed because of the presence of the insecticide we applied there. But as the week go on, you can see that when it comes to 3 weeks after, so 60% of them survived, only 40% of them were killed. And by the time when they reached 4 weeks after the insecticide has been applied, really there's not much effect. You basically have all of the billbugs survive. There's no difference compared to control group, which have 100% survival rate. So by saying that, unfortunately, the soil residual effect of those the insecticide we use to control the billbug adult does not last more than 3 weeks period of time. Another thing we want to consider is when you apply this type of insecticide to control the adult billbug, does that only kill the billbug? No, it also could affect the beneficial species. For example, ground beetle. You might not understand what a ground beetle is. Ground beetle is a beetle, just like a Japanese beetle. It's a nocturnal, and it's a beneficial because it hunts other insects as food. So it could kill the larvae of the white grubs. the larvae of Japanese beetle, for example. So that is beneficial species for us. So we conducted this experiment here at the University of Missouri as well. We again sprayed our oyster grass turf under the field, and 24 hours later, we brought the plugs back to the laboratory. We set them in the container, fill it with sand, and then the container is enclosed, and we released at least 6 of the ground beetle, which is collected under the field, to the container, and then let them stay or to be exposed to this sprayed plug to different time period time. So in this container, because they don't actually feed on turf, we also provided them food source. The food source is ground dog food. They appear to be happy with that, and also source of water in the cotton balls. And here's a short way to show you that when they're still alive, they're going to try to seek for shelters, and they will move being agitated, but compared to the dead one or intoxicated one, they will stay in the open area and not moving. And here's the data summarized from that experiment. You can see that if we expose the ground beetle to the insecticide sprayed turf plug for 4 hours, majority of them is going to be survived. But if we extend the exposure time to all the way to 7 days, you can see that little more than 10% of the ground beetle is going to be killed. So by saying that, when we use the insecticide there, we're not only potentially control the pest we want to control, we can also reduce the beneficial species that is undesirable. So throughout all this research here, and we found we actually had to go to the field to collect a lot of billbug for different study. We found that in the evening hours, it's very effective to be able to just spot them. If you train your eye to do that, just use a LED flashlight. You can see here is a billbug in the evening hours staying on the top of the turf canopy and zoom in what you saw here. One of my former students actually was pretty good. He could collect more than 150 billbugs within an hour period of time. And that led us to think about, are there any alternative way to control the billbug in order to reduce our reliance on the conventional insecticide? So this is a short video showing you at that time we borrowed equipment called the Little Cat, which is a turf sweeper, which is designed to sweep up the trash debris from synthetic turf. So understand that the high schools, those sports field, a lot of them are using the synthetic plastic carpet, and the trash or for example, people chewing gum fall on the plastic surface, they don't degrade very well. So there's a device designed to sweep up those debris. So we borrowed a piece of them from a local public school, and we just brought it to our one of our local golf course in one evening. Just crossed for 18 seconds. We see hunting billbugs there, another one there. So, and lots of the grass clippings being collected. So after we clean all those collections, we found that there are 48 hunting billbugs in just that very short period of time that we went through, no more than 18 seconds. So that led to our CTPM project. So this project was a collaboration with entomologists at the Utah State University and Purdue Universities. We have 3 objectives, and some of the objective has been completed, and we have paper published. And today's presentation, I just want to focus on the third objective, that is to develop this mechanic strategy to control billbug, to therefore hopefully reduce our reliance on conventional insecticide. So we set up this field experiment on a commercial local golf course on the oyster grass fairway. You can see this is each individual plot. This looks pretty big. This is 20 by 30 square feet. This is at the time we just set up the experiment, and we have installed 8 pitfall traps in each of the plots. So the treatment consists of 4 of them. Either we're going to use sweeping. We're going to sweep them 6 times in the spring or 9 times in the fall, because in the fall, based on our earlier biology data, we have a bigger window for the adult activity. And we also use Telstar bifenthral as our representative insecticide to spray. We either spray them in the daytime or the nighttime. The rationale behind that is at nighttime they could have more billbugs come up to the surface, because this insecticide work in contact, then maybe we might get a better efficacy out of that. And it was sprayed either in the spring and the fall, because we do have 2 peaks. Remember, one is spring, on the fall. So here just a simple summary graph of those 15 sweeping events. 6 of them happened in the spring and 9 of them happened in the fall. And this is the number of summarized per fall replicated plots of each sweeping event. You can see that the numbers could go higher than more than 100 Billbugs collected. So over the season from those 4 20 by 30 square feet plot area, we collected almost 700 hunting Billbugs. This is just one season's data. And remember, we also have 8 pitfall traps installed in each of the individual plot. So we check the pitfall traps on weekly basis, then we add them together. So we did this from April to November of that year, we add them together. Then this graph showing the average per each single plot, which is 20 by 30 square feet, how many of the Billbugs we were able to collect in the pitfall traps. So let's look at the control. Control throughout that season, we captured almost 250 of the Billbugs. And sweeping significantly reduced the Billbugs, ended up with only 150 in the pitfall traps. And what is the interesting thing is for the insecticide treated plots, regardless if the insecticide was applied in the daytime or late nighttime, they resulted in the same amount of the Billbugs in the trap and have the lowest amount around 100. So that is interesting. That means it doesn't matter we apply the insecticide daytime and the nighttime, they are as effective as each other. And then the sweeping compared to the insecticide ended up with 50 the Billbugs more compared to the insecticide applied plots, but still significantly, actually 100 Billbugs, around 100 Billbugs less than the untreated plots. Now, one thing I want you to pay attention is when you think about the entire plot, we have 4 treatment and 4 replication. So we have 4 of the 20 by, we have 16 of the 20 by 30 square feet plot area. So throughout this just one season, in those pitfall traps, we collected almost 2,500 hunting Billbugs. And also understand that those pitfall traps with diameter only 4 inches diameter. So the area covered by the pitfall traps that the hunting Billbug have to run into that area to fall and to be captured is less than 0.5% of the area of the entire plot area. So you can imagine how big the population really is there. And how would that translate to the turf appearance or performance? So this is turf quality visual assist. 9 would be perfect, 1 would be all dead. As you would have expected, the untreated control have the lowest turf quality, and sweeping generated pretty good turf quality, much better than the control. And what is the interesting result here is the daytime, the insecticide application result in better turf quality compared to nighttime. Despite that, both treatments result in the same effectiveness in terms of Billbug control. What could be the reason behind that? Our hypothesis could be the nighttime application insecticide probably have done greater damage to the beneficial species because lots of beneficial insects are nocturnal as well. Now here sweeping, of course, we only did 1 season. Already significantly improved the turf quality, even though it's not as great as insecticide, but don't forget that insecticide we applied twice. And by saying that, I'm going to conclude this presentation. So the first conclusion is we did find that sweeping is an effective way to remove Billbugs from the system when we did them when the adults are most active. And this would ultimately reduce our reliance on the conventional insecticide, and it would be most beneficial to the environment for long run. And this is a list of reference. And I would like to thank my collaborators for this project, Dr. Bruce Barrett here at the University of Missouri, and Dr. Richmond and Ender at Purdue University, and Ramirez, who is at Utah State University, and the founding agents from some of the turf organization, also the North Central SARE and the NIFA for the CTPM project. And I would like to answer any questions if there are any.
Thank you, Xi. Appreciate that. That was a great talk. Very interesting. So on your one question on your litter cat, it looks like it was safe to use on the real turf.
Yes, we didn't find any issue. At the beginning, we were concerned because that was designed for the synthetic turf, but we didn't find any issue on the zoological turf.
And those, it looks like those have to be used at nighttime then?
Oh, that's a really good question. Remember the video I showed, once we swept on the surface, we also collected lots of clippings actually from the thatch layer. Thatch layer would be the primary layer that the billbugs would hide during the daytime. So right now, our hypothesis is daytime could be as effective as nighttime, because the sweeper have those non-brushes. As you move forward, the brush will move over and bring those debris and thatch back to the collection bin. So our thinking is daytime could be as effective as the nighttime too. So that would be actually one thing we want to do the next step of this project.
That was going to be my question, was how many on golf courses, how many people would be willing to work in the middle of the night to go out there and use the sweepers? So,
you would be surprised. I actually have a local sod farmer, actually one of the biggest one in the Midwest, and he would be willing to go out in the evening hour because that save lots of money on the insecticide, also more friendly to the environment. Yeah, he borrowed our sweeper, so we ended up buying one for this project. But then you're right. So next step is to develop a strategy to utilize this device in the daytime, so people don't have to go out in the nighttime.
Well, great. Well, thank you very much. We've kind of reached the end of our time, but we really appreciate both you and Lee taking your time to do the webinar today. And I just want to let everybody else know that our next webinar will be on Wednesday, November 17th. And Diane Playwa from University of Illinois will be the speaker talking about the Illinois IPM program. If you want more information, I put it in the chat about our upcoming webinars, or to subscribe to our newsletter, which is called The Central Issue. You can go to our website, and it's ncipmc.org. So again, thank you everybody for attending, and thank you to our two speakers, and we will see you next month.